Okay, thanks gentlemen. So after our introductory lesson on arithmetic series, I thought I'd take you through a few word examples. They're not really, or word problems, they're not really wordy problems, but there are words around them. These are the things that tend to confuse mathematics students when you put words around numbers. So we're going to take a couple of problems today from Jones and Couchman on page 208 if you wish to refer to that later. Here's the first one. Find the S. I mean by that, find the sum of all positive, that means positive, integers less than 100 that are not divisible by 6. That are not divisible by 6. Alright, can anyone think of an overall strategy that might help us reach an answer? Now, by overall strategy, I'm not talking about detail, I'm just talking about the big logic that might sit behind this sort of problem. Yes?
Find the amount of integers divisible by 6 and then minus it off 99.
Okay, maybe what you're saying there is find the sum of the integers that are divisible by 6 between 0 and 100 and subtract that from the easy to find sum of the first 100 integers. It comes down to that, doesn't it?
So would you do 100 or because it's less than 100, or would you do 99?
Very good. You've got to be very careful with the language. It does say less than 100. Very good point. So let's just reread this. Find the sum of all positive integers less than 100 that are not divisible by 6. So yes, I think you would be looking at the sum of the integers between 1 and 99, wouldn't you? Right, as a first step. Very good. You wouldn't want to add on 100. Very good point. Of course, if it said less than or equal to 100, we would take it to 100. That's good. So I think that's what we might do first. The easy bit, settle the nerves. What we're going to do in summary is firstly find the sum of the integers that are less than 100. In other words, we're going to find the sum of this series, aren't we?
Yep.
And it's going to end at 99. 100 would be a fatal mistake there. Okay, so you know my philosophy on this. I like to be driven by the formula. So I've noticed already that we've got the first term and we already know the last term. When I know the first and last term, I am attracted to this particular formula. You could use the longer one. That's not a problem at all, but you are going to find that easier to work with. It's just shorter. Okay, firstly, I'm going to note down what n is. Quite plainly, it is 99. 1, 2, 3, there's no particular traps there, I don't think. I'm going to note down what a is, which is always the first term in any series, geometric or arithmetic, it is always the first term. And L is quite plainly 99, the last term. Okay, so that's going to equal, I should say, therefore, the sum, whoops, it's 99. Sum of the 99 integers is quite simply 99 divided by 2, and then I've got 1 plus 99. Well, that's going to be relatively simple to resolve. S99 equals, well, that's 49.5. Stumbling over my words there. 49.5 times 100, and therefore it seems that that part of it is going to be 49500. Okay? So I've worked out the sum of the integers between 1 and 99 inclusive. Good. So that's part 1 of that problem.
Too many zeros.
Too many zeros. I was wondering who would notice that first, so you're quite right. There we go.
Game stop.
Okay. Now, from that, it seems I've got to subtract the sum of the integers between 1 and 99 that are not divisible by 6. Sorry, that's what I've got to find out. So now I think what I'd like to find out is the sum of the integers that are divisible by 6 between 1 and 99. Does that make sense? Yeah? Okay, so what I'm going to do here is make use of what I've heard termed the telegraph pole principle to work out things like n. But which formula am I going to use here? Am I going to use this one or the longer version?
That one.
I'm going to use that one because I will certainly know the first term. The last term is not going to be difficult to find out, is it?
No.
I'm thinking it's 96. Okay? 6 goes into 96, doesn't it?
Yes.
Okay, it does. And I'm going to make use of the telegraph pole principle to find a value for n. So I'll have A, I'll have L, and I'll have n. Okay? And once I've found the answer to that, I will simply subtract my answer from the 4,950. Okay, here we go. So let's have a look at n. n equals, we've discovered that the last term in the series of integers that are divisible by 6 between 1 and 99 will be 96. So from that I'm going to subtract the first term that's divisible by 6, that'll be 6 itself, and divide by the common difference. And the common difference is plainly 6. It's going up by 6 every time, multiples of 6. Okay, so that's going to tell me that my answer is 15. But to that, I need to add 1, the telegraph pole principle. Okay, so that's a bit of dodgy mathematical notation, that, but I hope you follow the logic that's going on here. Yes, John?
16 plus 1. No, sorry. No, I didn't say minus 6. Never mind.
Yeah. Okay. So n equals 16. Alright, I'm ready to go now with finding the sum of the integers that are divisible by 6 between 1 and 99. Okay, so here's my homemade notation. The sum of the divisible by 6's is equal to 16 divided by 2, bracket, the first number in our sequence. I haven't written it out yet, or at all. I'm not going to, but it's 6, and the last one is 96. Okay? So, sum of the integers that's divisible by 6 is 8 times 102. And that equals 816, doesn't it?
Yep.
Okay. So my answer, remembering what the question is, find the sum of all positive integers less than 100 that are not divisible by 6, is simply found by subtracting the 816 from 4,950. And that is going to equal 4,134, is it? Okay. Thank you very much. That is that problem done. Any questions? No? Do you want to stop the...